All right, so today is just like yesterday. Okay, we're doing the same two-column proofs, statements on the left, reasons on the right. We may use some of the properties of equality we talked about yesterday, but we can only use those if there is an equal sign that is present, which should make a little bit of sense. The properties of equality only work when there's an equal sign. When we talk about segments, we're talking about shapes, so we're no longer talking about things that are equal, but rather things that are congruent. So along with our congruent statements, we're going to get some properties of congruence. Come on, words. So our first one, the reflexive property of congruence. For any segment, in this case, segment is AB, we would say segment AB is that looks just like our reflexive property of equality from yesterday. But because there's no equal sign, it's the reflexive property of congruence now. Symmetric, what do you think? If AB is congruent to CD, if we think about yesterday's symmetric, anybody got a guess? CD to AB, good. CD is congruent to AB. What about transitive property of congruence? If AB is congruent to CD and CD is congruent to EF. If we think transitive, what do you think is going to be our conclusion? AB is congruent to EF. Great job. So what's the only difference between the rules that we learned right here today and the rules we learned yesterday? What's the difference? That's a great answer. The only difference is today we've got a congruent symbol, whereas yesterday we had an equal sign. Segments are congruent if and only if. What's that? What do we call that statement? If and only if. Because that's still this unit, and that will be on the test. Close. Further away. It was with our conditional statements. If and only if, biconditional. Good. That's a biconditional statement. Segments are congruent if and only if they have the same measure. So what it means is, if segment AB is congruent to segment CD, then the length of AB must be equal to the length of CD. That means segment. Yep. So if segment AB is congruent to segment CD, then the length of AB must be equal to the length of CD. And because it's a biconditional statement, I can also say it the other way around. If the length of AB equals the length of CD, what could we also say? Segment AB is congruent to segment CD. So remember, numbers are equal. Sides, angles, all that jazz, if we're naming them, those are congruent. Have you guys seen midpoint before? Okay, so if we haven't seen it before, what do we think when we hear the word midpoint? It's in the middle. So when I tell you something's in the middle of math, what does that tell you about the other two pieces? That they're equal. So if something is a midpoint, we would say the length of AM equals the length of MB. Or you could say segment AM is what to MB? Congruent. That's the definition of a midpoint. Segment addition postulate, another new one. A, B, and C are collinear. What's collinear? What was coplanar? On the same plane. So what do you think collinear is? On the same line. And B is between A and C. The length of AB plus the length of BC equals what? AB plus BC equals, what do you think? AC, the full length of the line, absolutely. Are y'all ready for another fascinating round of Name That Property? Yeah. Name that property. Justify each statement below using either the property of equality, a property of congruence, definition, or postulate. How do we tell the difference between equality and congruence? Property of equality has an equal. Property of congruence has a congruence. Equals out on the mustache. Yeah. So if PQ equals PQ, then we can conclude that segment PQ is congruent to segment PQ. What do you think? What do you know, Joe? What's our rule? Number equals a number, then segment equals a segment. Y'all can go back to the page before. It is not cheating for 100. It is the definition of congruence. If K is between J and L, then JK plus KL creates JL. What is it? Segment addition postulate. Good. EF is congruent to EF. The same is the same. Reflexive property of congruence. Reflexive property of congruence. If RS equals TU, then RS plus XY equals TU plus XY. What'd they do? What'd they change? Somebody just showed up. Who showed up to the party? XY. How did he get in the party? Did they substitute him? Did somebody get replaced? What did they do? XY showed up. What's in front of XY? A plus sign. Is there a plus XY on both sides? So who invited him? Which property? What is it? How'd he get there? If he got there with a plus sign, what property? The addition property of equality. It's from yesterday. That's what?
We use those on these.
Yeah. They're going to stack on top of each other like a delicious stack of pancakes at IHOP. It did. Justify each statement using a property of equality.
Do we walk
Sure.
Run out?
No. If AB equals DE, then DE equals AB. Congruence or equality? Which one? Is there an equal sign or a congruent sign? Equal sign. So is it property of equality or property of congruence? Equality. You weirdos. If y is the midpoint of xz, then xy equals yc. Definition of midpoint. Y'all can go to Waffle House whenever you want to. Like she said, I can't technically stop you. I mean, if you get up and walk out, there's nothing I can do about it. Just know you ain't gonna be welcome back in here.
Wait, aren't you our guardian for this time? Because in Mr. Vide's class, he said that he is our guardian for the time that we're in this class. So if he lets us go early and we go out and get hit by a car, he's responsible for it.
I don't know the legality of that situation.
Aren't you responsible if we get hit?
I mean, you're a consenting young adult, so if you choose to walk outside and get hit by a car, if I gave you permission, I don't know. It's weird. If FG is congruent to HI and HI is congruent to JK, then FG is congruent to JK. What happened? What changed? We don't have a translation thingy. Why is it transitive and not substitution? Substitution is when somebody replaces. Transitive, somebody dropped. So somebody dropped out, so we've got the transitive property. Equality or congruence. The HI. So they said HI was equal to both, or congruent to both, so we can just drop him out of there and skip the whole HI step. Equality or congruence? Why equality? We are on 7. Congruence. Why congruence? There's a congruent sign. AB plus CD equals EF plus CD. Then AB equals EF. What changed? How did they get rid of CD? Not substitution. Not transitive. How would I get rid of CD in that first equation? Subtraction. They subtracted CD. What's that?
I think the capital letters are throwing me off.
Are they? That's how we label sides and angles in geometry. If PQ plus RS equals TV and RS equals WX, then PQ plus WX equals TB. What happened? What changed?
Did they replace RS with PQ?
Nope.
Substitute?
They didn't replace RS with PQ. Who did they replace RS with? WX. What do we call it when somebody replaces another? Substitution. Absolutement. Ln and P, Ln equals Pn. L, P, and N are collinear. P is the midpoint of Ln. Definition of midpoint. It's got midpoint in it. Magic. The definition of a midpoint. I'll find a midpoint soon. Put a little bit more math back in our math. What do y'all think? If segment UV is congruent to segment VU, or UV, what? UV is congruent to UV, then UV equals UV. If we go from congruent to equal, what are we doing? Not transitive, because we're not replacing anybody. What you got? Definition of congruence. Yeah. If we're bouncing back and forth, because angles that are always congruent are always going to be equal. Angles that are always equal will always be congruent. So definition of congruence. Did you tear up my daggum window, son? Are you sure? Okay, well, I'm not worried about you. I'm worried about the thing. Be tearing up my classroom. If CD plus DE equals CE, then CD equals CE minus DE. What are they doing? What changed? What did DE do? Hey, what? How did it become a negative? This ain't superhero comics. It doesn't just become negative. Stepped in a puddle. Radioactive man. It's subtraction property.
If we use the subtraction and you take it off, like you take it off.
Well, your test is always what? Multiple choice.
Oh, let's go.
So the answers will be there. You just got to be able to diversify your portfolio. What's that? If 2x equals xz, then xy equals 1/2 xz. What'd they do? What changed? Your chair's got 4 platforms. Please use them all so you don't crack your head open. My man, thank you. Yeah, please don't bleed on my floor. Yeah, we go there in mourning of your honor.
I'll take you.
All right. What changed from 2xy to 1/2 xz? What'd they do? They divided. Good job. Division Po. If RS equals ST and ST equals 2UB, then RS equals 2UV. What you think? What you know? Joe? Is it too much early in the morning? Yeah. And you want Waffle House? If y'all all average an A on your next test, I'll bring y'all Waffle House. All right then. And it's just y'all's average, not all of geometry.
Ethan? Huh?
Did you just ask to cheat?
No. I'm smart. I didn't have to say.
I mean, Ethan did get 109 on the quiz.
What? I did? So, wait, what?
Yeah. Transitive.
Just 'cause, like, I don't have someone talking.
Well, there's no talking during the test, so you're good.
They'll be like, talking to our next.
You got Lydia. Lydia's pretty talkative. And Sean's just a ball full of energy back there. Apparently. All right. So as we go through our proofs, these are our reasons bank. These reasons can be any of the reasons for our proof. Okay. So here we go. So you can kind of see it's sideways. Is it sideways for y'all too? It's okay. So number one, these are the reasons that we're going to use. The addition property, given, transitive property, definition of midpoint, segment addition postulate, and simplify. Because the computer's smarter than you. All right. So think about those reasons. Those little reasons in that box are the reasons. That's kind of what's going to happen on your test. You'll have like a little situation you can choose from, and then you just got to put them in the proper order. All right. E is the midpoint of DF. Prove 2 DEs equals 1 DF. You got to lock your screen if you're going to rotate it, son. I don't know. Sure. All right. So E is the midpoint of DF. How do we know that information? It's given. It is given. Our first reason will generally always be given. So if you're following along at home, we can go ahead and cross off given. Look at that. You don't have to. I just did. You ain't got to. Well, how about this? Let me see if it gives you like a word bank.
Oh,
Maybe. Watch this. Let's see if I can be a ninja. Nope. No ninja. Oh well. All right. DE equals EF. How do we know that? So with our segment proofs, we can kind of use what happened before to guide us in the direction we want to go. How do I know segment DE equals segment EF? Yes, ma'am. Definition of midpoint. How did you come to that conclusion? What did it talk about in our first step? E is the midpoint, so it's hinting where it wants you to go next. So you are 1000% correct, madam. DE is equal to EF. That is the definition of midpoint. So we can cross that off of our word bank. Look at that, we're closing out. Now we've just got the addition property, the transitive property, segment addition postulate, and simplify. DE plus DE equals DE plus EF. Yes, sir.
What is the segment addition process?
It's when two segments are being added together to create a third. What did they do? DE plus DE equals DE plus EF. This is a little tricky. When you look at your word bank, what do you think? Oh, Peter.
okay, go.
Don't die on me, Peter.
We all get corona, okay?
Calm down, son.
And then we quarantine at yeah.
But you come too.
Why would I want to go? If y'all are all quarantined at the daggone Waffle House, why would I want to go?
No, that'd be sick.
No, if we have a quarantine, you definitely want to.
We can eat waffles all day.
That does not sound good.
That sounds so good.
All right, so addition property, transitive property, segment addition, or simplify. If those are my four choices for this step, which two can you guys eliminate? Simplify, that's a good elimination, and what else? Segment addition. No, I probably don't want to eliminate that one because that one could be a chance. Because we've got DE plus DE equals DE plus EF. You can, okay, so we're going to eliminate transitive, eliminate simplify. So we've just got to figure out, is this step showing addition or is this step showing segment addition, where two segments are coming together to make a bigger one? Addition. Why? Why did you say addition and not segment addition? Oh, you can see segment addition on there. Okay.
Wait.
How did they get 2DE equals DE plus EF? What's that? They added what? Did they cross an equal sign when they added them? What'd they do? They simplified. What do we call that? A big old CLT sandwich. Or it could be simplify. No waffles for you. DE plus EF equals DF. What do you think? What do you know? Segment addition postulate.
SAP.
What's that?
SAP. What's it called?
As long as you know what SAP means. They are your notes. And then 2DE equals DF. What'd they do? How did they get 2DE equals DF? They said 2DE equals DE plus EF, and DE plus EF equals DF. How did they draw this conclusion? Why? Transitive is the one where if A equals B and B equals C, then we could just drop B and say A equals C. Who did they drop here? They didn't drop DF because he's still there. They dropped the DE plus EF on both. So when I look back, I've got that DE and EF. Those are just going to get dropped off, leaving me those two. So what do we call it when something drops? Transitive property. And boom, you guys just did your first, I would say, real geometry proofs. The ones yesterday were algebra. It'll be all right. Y'all did great. Let's look at number 2. Given KL is congruent to LN, LM is congruent to LN, prove L is the midpoint of KM. So how do I know KL is congruent to LM? Or KL and LN is congruent and LM and LN is congruent? They gave it to me. Given. How do I know KL equals LN and LM equals LN? They went from congruence to equality. What do we call that? Definition of congruence. KL equals LM. What do you think? So what happened? What'd they do? How did they go from KL equals LN and LM equals LN to KL equals LM?
Oh, I think they're getting rid of something.
They got rid of something, so something dropped. LN dropped. So what do we call it when somebody drops? Transitive. Look at you guys. How do I know that L is the midpoint of KM? I would have liked to have shown one more step here, but it's okay. How do I know that L is the midpoint of KM? What's that?
Because it's in the middle between K and M.
Okay, so it's in the middle, but how do we know it's congruent? How do we know that they're equal?
Because they're all the same one.
It says it at the top. They're the same length. So if two segments are the same length, their point is in the middle, how do we know that makes them equal? Definition of what? Definition of midpoint.
If it doesn't say midpoint in it, or it always going to say midpoint, and like the definition of midpoint.
Yes. Generally speaking, it will say midpoint in that step, or like the one earlier, it'll say it before that step.
Are those kind of given in a way?
Are those kind of given a little bit? Yeah. Yep.
Coach, we have a word on it.
What's that?
Do we have homework tonight?
Do we have homework tonight? You bet your tail we got homework tonight. You've got math homework every night, Protein Shake. Oh gosh, I'm glad I'm making one by moments. Number 3 is a little longer. I like it. It's a lot of letters. Oh, Peter.
Oh, Peter.
All right. Given PQ is congruent to TQ and UQ is congruent to US, prove PS is congruent to TU. So I'm going to let you guys in on a little secret. When we mark up our figure, it's going to help us. So Q is congruent to TQ. So I'm going to say the little, and then the little tick mark signifies congruence. PQ to TQ, UQ to QS. Tick mark signals congruence. Because we don't necessarily know that those are congruent to the others yet. We might be able to prove it, but we don't know yet. So PQ is congruent to TQ and UQ is congruent to QS. How do we know that? How do we know that? What do you think? What do you know? How do we get that piece of information? It's given. Absolutely. That's given to us. What's the first step in any two-column proof? It's always what they give us. All right, numero dos. PQ equals TQ, UQ equals QS. What allows us to bounce back and forth? If something's congruent, then it's equal. And if something's equal, then it's congruent. What is the definition of that? Negatory. Definition of congruence. It allows me to bounce back and forth between equal and congruent. So definition of congruent. PQ plus QS equals PS, and TQ plus QU equals TU. Where did they get that from? What'd they do? What does PQ and QS make up? PS. And what does TQ and QU make up? QU. So what allows us to say two smaller segments combined? When their powers combine. Earth, wind, fire. Captain Planet. Segment addition postulate. Y'all don't know Captain Planet? Because you're adding two smaller segments to make a bigger one. TQ plus QS equals PS. TQ plus QS equals PS. Where did they get that from? Transitive? What do you mean transitive? What is it? Well, let's look at the step before, because it looks pretty similar, right? 3 and 4, PQ plus QS equals PS, TQ plus QS equals PS. What changed? Something changed. What changed? Okay, PQ became what? TQ. Did something drop out or was something replaced? It dropped out? Why substitution? What's that? It is substitution. Okay, and if we go back to step 2, so let's see, you guys kind of see. So if we go back to step 2, they took that information with our first segment addition. They said because PQ equals TQ, PQ can be replaced by TQ. Nobody dropped out. It got replaced. Okay. What about 5? TQ plus QS equals TU. What'd they do? Here's a hint. It looks an awful like what we just did before. It dropped out or did it get replaced? What got replaced? PS got replaced with who? How did it, what allowed me to do that?
They're kind of popped up on now. Is that the replace?
So TU got replaced with PS, right? Where substitution from where though?
There's not another substitution on the thing though.
There's 2. There is 2. There is another one on the word bank. Substitution from step 2 and 3. But this time they told us who got substituted. What's that? PS. So they know, whoopsies, that TU is equal to PQ and QS.
So do you want to go back in your statement?
Yes, you may have to go back up top and get pieces. So it's just like a big puzzle we're trying to get put together. Now what? TQ plus QS equals PS. TQ plus QS equals TU. They just said PS equals TU. Now translation, why? Somebody dropped. Who dropped? Can't write in highlighter, dummy. What's that? Yeah, that sum dropped out of there.
Then the TQ became PS.
What's that?
The TQ became PS.
TQ became PS. So if we, oh gosh. So if we look at 5 and 6, they both have TQ plus QS equals, right? So we can drop that out and just take the last pieces. All right, and then how do we know PS equals TU? Definition of congruence. The definition of congruence allows us to bounce back and forth. Ain't this fun? No? They're like, we have very different word methods of fun than you, Coach.
You know what's fun?
Yes, sir. Waffle House is fun? How do you know?
What?
How do you know?
Because I'm in there one time.
You went in there one time? Oh. Just the once?
Nope.
Oh.
Many times.
Again, if y'all get it, listen, it's on video. If y'all average an A on the next test, I'll bring in 13 waffles.
Field trip. Field
No, we
trip
can't go there. They're not gonna let me take y'all out. Yeah. I mean, I'll put on the little hat and everything for y'all. Maybe make some hash browns, some eggs. All right, we'll do one more because we got time. All right, given that K is the midpoint of JL and M is the midpoint of LN, JK equals MN, prove KL equals LM. How do we know K is the midpoint and M is the midpoint? It is given. First line will always be given. So how do we know JK equals KL and LM equals MN? What's our hint? What's our context clue from the step before? What's it talking about in the first step? Midpoint. So what's our next logical step after that? Show the midpoint, right? The definition of a midpoint. This is you guys' first foray into multiple of something. How do we know JK equals MN? Nope. How do we know JK equals MN? What do you think? Nope. Look back at the problem. What'd they tell us? It's given. It's part of the problem. So you guys could end up seeing given showing its face multiple times. Now they tell me MN equals KL and LM equals MN. What changed? Look at steps 2 and 3. What changed? Why transitive? Who dropped? Did JK drop or was JK replaced? Replaced by whom? What's that? So MN was replaced JK. Do you see it? So that's our substitution. Steps 2 and 3. And then you guys don't have to write out this whole like step 2, step 3 thing, but it just helps you kind of organize what's happening. Number 5, LM equals KL. What happened? How'd they go from 2 problems to 1? They dropped them in. What do we call it when somebody drops? Transitive. KL equals LM. What'd they do? Yeah, symmetric property. They just flipped it around.
So if we switch it to metric. and
Yep.
then lines over congruent.
Yep. And then how did they go from KL equals LM to KL is congruent to LM? What allows them to do that? Definition of congruence. Definition of congruent. All right, let's look at how much homework y'all have. Oh, that mean old teacher.
Come on, kids, you're all good.
What? How about this? Y'all do, you ready?
First page roll.
So you're going to do 1 through 3, 4, 6, and 8. 1 through 3, 4, 6, and 8. 1 through 3, 4,